Daily reminders. First reminder is that you have a test coming up in a little bit more than a week on the 21st. That short week, we got, we'll take a test on that Tuesday that you guys, basically the one day that everybody has class next week, or week after, I should say. Okay? For those of you that do have class tomorrow, so for those of you in my two grading sections, there is nothing on the schedule tomorrow in class because Schmeling classes will not meet. So we can't teach during that day because his classes don't meet. Okay. So tomorrow we can watch videos, we can watch a movie. I don't care what we do tomorrow in class. So yeah, we can play games. We can play Hangman. I don't really care. Okay. Next week, then we've got some review, and then that test. Again, your unit circle projects are due on the 28th, which is after the long weekend. Okay? So we took the quiz already. So let's talk angles here now in standard position. For those of you that have been paying attention in class, well, these 6 weeks into school now, you'll know, or you should have picked up on the fact that I don't really like to use true mathematical terms. I like to put things in a more common vernacular, if you will, more common language, so that you can easily remember it, so you know what we're using it for. Okay. Today, for this first one, you know what the measure of an angle is. I hope you know what the measure of an angle is. But today I'm going to teach you the true mathematical definition of what the measure of an angle is. Okay? So the true measure of an angle, first off, before we even talk about what the true measure of an angle is, we need to first define a couple of parts of an angle. Okay? So an angle is made up of two distinct parts. Okay? The first part is called the initial side. Okay? That is the first part of an angle. Then there is something called the terminal side. Okay. The initial side, initial means first, beginning, if you will. It's where the angle starts. Terminal, meaning end, is where the angle then ends. Okay? And those two sides meet at the vertex. Okay? Those two sides meet at the vertex. So the true measure of an angle is the amount of rotation around the vertex from the initial side to the terminal side. Yes, I had to read it out of the book so that I got the wordage right. side to the terminal side. Okay. Positive angles then are measured counterclockwise rotationally. Okay. So a positive angle would rotate counterclockwise around to it. Okay. A negative angle, I didn't use pink over there. Okay. A negative angle would have clockwise rotation. An angle in standard position has two characteristics. The first characteristic is the vertex is the origin. Okay. That's the first characteristic, is that the vertex is at the origin. The second characteristic is that the initial side is on the positive x-axis. So our red-green angle that we started with as our, to get our terminology, that is an angle in standard position. Vertex is at the origin. Initial side is on the positive x-axis. Okay? Which also means that all of your unit circle angles are angles in standard position, because we start with 0 here on the positive x-axis. And then we rotate counterclockwise, stay, and we rotate counterclockwise for positive angles. We will rotate clockwise for negative angles. Okay. Now, there are also things out there called coterminal angles. Okay? Coterminal angles are angles in standard position with, did I say not congruent? With the same, with the same terminal side. Okay. So for instance, the angle negative 150 degrees would be kind of right there. Drew it too far out. There, kind of like right there. Okay. Where this angle here is negative 150 degrees. Do we all agree with that? Okay. A coterminal angle would have the same terminal side. So we could say here that 210 degrees is coterminal with negative 150. We could say that (570 degrees is coterminal with negative 150. We could say that, see if I can get it inside. We could say that negative 510 degrees is coterminal with negative 150 degrees. We could say that negative 870 degrees is coterminal. We could say that negative 1230 degrees is coterminal. How am I getting those so quickly? Adding or subtracting 360 to it. Yep, exactly. Okay, because that's one more lap around. All of those are coterminal with it. Okay? 2 pi over 3 is up here. You give me a positive and a negative coterminal angle with 2 pi over 3. You should have one of them on there. Those are the first 3 positives and first 3 negatives. How did I get those so quickly? What am I adding or subtracting this time? 2 pi, but I'm not really adding or subtracting 2 pi. I'm really 6 pi over 3. Yep, I'm really adding or subtracting 6 pi over 3. Okay? So the next one in the positive would be 26 pi over 3. Next one would be 32 pi over 3. Next one in the negative would be negative 22 pi over 3, negative 28 pi over 3. Okay? Good times. Reference angles. Okay? A reference angle is 2 things. Actually, there's many things that we're going to talk about a reference angle. First thing, its symbol is theta prime. Okay? That will be the symbol that we will use for a reference angle from now until May. Okay? Is theta prime. Okay? A reference angle is an acute angle, meaning it is less than 90 degrees or less than 2 pi radians. Okay? It is an acute angle. The most important thing is that the reference angle comes off of the horizontal axes. Yesterday we talked about angles of elevation and angles of depression, and I made the comment that everything in math, in terms of angles, comes off of the horizontal. Okay? So angles of elevation, angles of depression, and reference angles all come off the horizontal. Okay? So it says find theta in standard position if the terminal side of the ray goes through the point -2, -3. Well, first off, we should draw ourselves a little sketch, a little picture of where this angle actually is. Right? -3, -2 would be down here in quadrant number 3. Do we all agree with that? Okay. With me? Okay. If I were to make a triangle out of this, what would this side length right here be? Side length. 3. Okay. Yes, it would be -3, but because it's a side length and we're using it as a triangle, okay, we're going to call it +3. What would this side length, this vertical side length here be? It'd be 2. Okay. Now, this is a right triangle, which makes me able, or allows me, to find this angle right here, which is my reference angle theta prime, because it is coming off the horizontal, and SOHCAHTOA can only find me acute angles, because it's right triangle, and there is no obtuse angle in a right triangle. Okay? So we can say here that the tangent of theta prime is equal to the opposite over the adjacent. Use a little TOA action. Which then would mean that our reference angle theta prime would be equal to the inverse tangent of 2/3. Okay? Now, depending on which calculator you are going to be using, we need to find the inverse tangent of 2/3. The first thing that I would recommend is if you are using one of our calculators, that you go up here and you switch that 2 degrees. Okay? Because then you will get the degree measure of your acute angle, your reference angle, if you will, not the radian. And then you'll have to convert it. Then it's just simply trig, inverse tangent of 2 divided by 3. Don't use 0.66 because it won't get you the exact answer. And some of you found out on the last couple of tests that we do exact answers and we round only at the very, very end. Okay. So I get 33.6901 for my reference angle. Okay. So that is my reference angle. My actual angle theta starts here and comes all the way around to there. So my actual theta would be 180 degrees plus that. So theta here would be, what would that be? 213.690 degrees. don't believe. Okay, so you're going to have to find a little space for this next one. Okay, so if you have an angle, okay, in quadrant number 1, actual theta is equal to theta prime. In quadrant number 1 only, actual theta is equal to theta prime. In quadrant number 2, actual theta is 180 degrees minus your reference angle, or pi minus your reference angle. Oh, thought I had my charger. We'll grab my charger quick. In quadrant number 3, actual theta is 180 degrees plus your reference angle, or pi plus your reference angle. And in quadrant number 4, actual theta is 360 degrees minus your reference angle, or 2 pi minus your reference angle. That would be your reference angle. This would be your reference angle. This would be your reference angle. This would be your reference angle. Okay? Your reference angle always comes off the horizontal. Utilizing that information, find me those 3 reference angles. All right, so reference angle for 125, I need to get to 180. So the reference angle would be 55 degrees. For 220, I'm 40 degrees past 180. For 310, I am 50 degrees shy of the x-axis. Questions on those, or want me to show you them? Good? What's up?
How do you do number, like, I just don't understand, like, how we just changed a different way to number 2.
Number 2? Okay.
So they go into 270.
Because they always come off of the horizontal. 270 would be the vertical. Okay? So 220 is down here. So here is 220 degrees. So this right in here would be my 40 degree reference angle. Always off the horizontal. Okay? If theta is in standard position with the terminal side of theta through the point x comma y, find the sine, the cosine, the tangent, and actual theta. Okay? So theta goes through -5 comma 12. -5 comma 12 would be up here in quadrant number 2. So this is actual theta. This would be theta prime. Theta prime makes a triangle that has 5 for one side, 12 for another side. What would the hypotenuse then be of said triangle? 13. Yep, it would be 13 because that is a Pythagorean triple. One of those that you should just memorize. 3, 4, 5, 5, 12, 13. Memorize those 2, okay, for sure. Okay? So right off the start, we can say that the sine of theta is 12/13. Because I am in quadrant number 2, that sign is positive. That was an obviosity. Okay? We can say that the cosine of theta is -5/13. Because it's in quadrant number 2, cosine is negative. We can say then that the tangent of theta is -12/5, opposite over adjacent. If you wanted to think of that 5 as -5, you by all means could. Okay. Now we just have to find our reference angle, theta prime. That's going to be the inverse tangent of 12/5. Makes you have a quizzical look on your face. Because now we're in the triangle, so now we can't use the negative. We have to use the positive now. Okay? Alright? So when we do that inverse tangent of 12/5, I get 67.3801. 67.3801 degrees. Everybody with me on that? Okay? Alright? What's up?
My calculator is
Go up to the, use your trackpad, go up to the radian, and push the middle of your trackpad. We are in quadrant number 2. Since we are in quadrant number 2, actual theta is going to be 180 degrees minus my reference angle. So in this particular case, actual theta is going to be 180 minus my answer, 112.620. Third floor, Linsmar, I do have a question for you.
Is it what do you get when you divide 2 by 3? And the answer is 6, 7.
6, 7.
6, 7. 6, 7.
Wait, no. Oh, yeah,
Agree? Tangent sine is -4/5, cosine is -3/5, tangent is 4/3, and my actual theta is 233.130 degrees.
Why is the tangent positive?
Because it's in quadrant number 3. Negative divided by a negative is positive. Yep. Yep, that's why. Good. Thanks for playing along today.